The Sheridan College created the Integrated Energy and Climate Master Plan. What is it about?
Well, like most institutions with a couple million square feet of buildings and vintage of buildings from 1970 to now, Sheridan has a number of the same pain points you'd find in almost any organization. Things like escalating utility costs, things like a long backlog of deferred maintenance, things we haven't been able to get to. So deteriorating systems inside our buildings, as well as difficulties with the building envelope. So the Energy and Climate Master Plan was our attempt to develop a portfolio of energy projects, to put them together in a package that would be attractive financially, yet allow us to achieve really deep savings on campus. So reductions of 50% or more in energy consumption, carbon reduction kind of in similar levels, a really aggressive plan. So we managed to get that approved by our Board of Governors in 2013. We've been implementing ever since. The types of things in the Energy and Climate Master Plan include gaining control of our systems, so improving our building automation, repairing mechanical systems, fixing the building envelope, so sealing against air infiltration, improving solar gain problems, all of those kinds of things. And then we've really tackled the what we call supply integration, so making sure we can get heating and cooling from building to building without losing a lot of the energy on the way, and then really improving the supply side so that we're making better use of the fuel we're putting in, using a combined heat and power engines to provide our baseload heating as well as some supplementary electricity. In the summer we use that CHP engine to drive absorption cooling, so we actually get a double benefit of electricity reduction plus additional cooling.
So according to the climate plan, the Sheridan College has begun the construction of its new district heating and cooling system at the Trafalgar Campus. What are the reasons for following such a project, and what will be the benefits for the college?
So the college has really gone fully into a pressurized hot water network. The convention in North America has been steam systems, and we have some legacy steam systems within our campus. We find them extremely lossy. The studies show that as much as 25% or more of the energy is lost. Steam energy is actually lost before it reaches end uses, and that's not an acceptable situation when you're trying to save energy. So we've really tried to pull in the European practice, which says use a highly engineered pipe system, design it for your campus. These manufactured components obviously have high durability, lots of good feature sets, lots of support. They're very, very good products, these pre-insulated pipes that we're dropping in the ground. And then that stuff is fed with CHP engines, with combined heat and power. So in effect, the natural gas that we're putting in is getting something like 75–85% utilization, which is obviously to our benefit. So it not only means that we're getting most of our investment in fuel, but it also means that we're getting the benefit of low natural gas prices right now. So compared to the cost of electricity bought from the grid, particularly in Ontario, what we get in terms of generating from CHP comes at us at much lower cost. So real big benefits for us.
What actions is the Sheridan College pursuing to become a zero-waste campus by 2020?
When we engaged our stakeholders about what would they like to see in a waste program, they almost unanimously said, we want a really aspirational goal. We'd like to try to get to zero. And so they've been pushing us to try to achieve this goal of getting to zero waste. And it's really quite an ambitious goal when you think about all of the work that would go into trying to get to no landfill waste. It really started for us with making sure that everything we had going into waste streams was being properly separated. Prior to initiating the program, everything kind of ended up in a mix of bins. And so with the new sorting, we've been really working with the community on getting organic materials separated out from recycled materials to landfill materials. That first step probably got us to 50–60% diversion from landfill, which is a pretty decent start. To get to the next level, we really need to deal with the on-site processing of our organics so that we can actually close the loop on what happens to organics once they've entered our bin. Can we put them to use on campus and not ship them elsewhere? And then really work on feedback to our user community about what they're actually putting to landfill and why it's there. And they're going to have to do a lot of homework with us on how to reduce the amount they're putting in to begin with, how to actually reuse some of the stuff they're putting in, and then we're going to really work together to get to zero.